Hi, now we're going to see an application where we have what we call fixed flow, meaning that the flow will not vary at any time. It could be a cooling or heating coil, which I have tried to illustrate by the box over here. So the application could look like this, where we have the pump, we have a non-return valve, and we have a motorized valve which will actually adjust maybe the temperature which is on the blown in air on the other side of the cooling coil. But actually we do have another piece of equipment here, and that's the throttling valve. And why do we need that at all? Well, we need to look on a pump curve, and if we have calculated that the actual flow for a system like this could be something like this, and the equivalent pressure loss could be on a level like this, then, as already mentioned, if it's a fixed flow application or system, then you could argue that there's no need for choosing pressure controlled pumps. So what we do then is that we look for a pump with free speed. But as we can see, the desired duty point is not on either speed 1, 2, or 3 here. So we need to do something different. Well, what we do then is that we accept that the pump will operate on speed 3, and then we increase the pressure loss, so to speak, the pressure resistance in the system by adjusting this throttling valve up here. And thereby we secure that we are not exceeding the exact flow which is calculated for the system. This is one way of doing it, but actually there's a second way which I would like to show you now. Well, instead of choosing a 3-speed pump, we could do like this. We could simply choose a Magna 3 pump here, and then tell it to operate on maximum curve, maximum rounds per minute. And of course then you would not know if you have this flow or this flow, or if you exactly have this here, because then it could be difficult. But what you can do is that you can put it to operate on maximum, and then simply enable the flow limit function. And that will tell the pump never to exceed this line here. And in reality, what it will do is that it will create a specific pump curve which will go exactly across this duty point here, or desired duty point. So in that way, the pump itself will find the right round per minute to achieve the flow and head which is needed for the system. And in cases like this, we can simply eliminate the use of the throttling valve and then save this and allow the system to operate based on flow limit. And that's an innovative way of utilizing the features in the Magna 3 pump. I will encourage everyone to try it out. Thank you.